We've been looking at solving traveling salesman problems using the nearest neighbor algorithm. In this example, as opposed to having the weights recorded for us on a graph, we are going to have the weights recorded for us on a table. Now in this table, the weights are going to be miles between two different cities. So we have the 6 cities in Virginia: Alexandria, Harrisonburg, Norfolk, Richmond, Williamsburg, and Winchester, which you can see repeated across the top and then across the side. The distance from a city to itself is 0, so that's represented by these asterisks along the diagonal. We can see here that the distance from Alexandria to Harrisonburg is 121 miles, which is also repeated over here. The distance from Harrisonburg to Alexandria is still 121 miles. So you're seeing this symmetry across this table, that it doesn't really matter then what city we grab from over here on the left versus what city we grab over here on the top. We're going to get the same mileage either way. So for instance, the distance from Richmond to Norfolk is 93, or I could have looked for the distance from Norfolk to Richmond. It's still going to be 93. Now ultimately, using this mileage chart, we're going to find the nearest neighbor tour, which is going to be the circuit that we generate from running the nearest neighbor algorithm. We're going to start in Richmond, and we're going to then state the weight of the tour, and we're going to record the weights in the order found as dictated by the algorithm. We're actually going to be able to solve this problem without creating a complete weighted graph. We're just going to use the information in the table. However, I want to show you what a complete weighted graph would look like for this scenario if you had decided you wanted to make one to kind of have that visual reference. So I'm going to have these 6 cities. So I tend to, when I make my graph, I tend to put them in a circular order. So I'll have Alexandria, Harrisonburg, Norfolk, Richmond, I'm trying to use the same abbreviations, let's see, so I've got the 4, I'll have Williamsburg, and Winchester. Alright, now there is going to be a way to get from any one of these cities to any of the other cities, so I'm going to have to now draw in my edges. So from Alexandria, there will be a way to get to Harrisonburg. So maybe I'll make these vertices a little bit bigger. There'll be a way to get to Norfolk, Richmond, Williamsburg, and Winchester. Every one of these edges will have an associated weight. So from Alexandria to Harrisonburg, that's 121. From Alexandria to Norfolk, that'll be 190. Alexandria to Richmond, 104. Alexandria to Williamsburg, 148. And then Alexandria to Winchester, 70. Now ultimately this is going to be a complete weighted graph, which means from every one of these vertices, so from Harrisonburg I would have connections then to, I don't want to do that. We'll just draw it straight in. Winchester, Williamsburg, Richmond, and Norfolk. So from this one I already have 2 of the cities connected, so then I just need to draw in these 3 more. Richmond already has 3 connections, so I just need to draw in 2 more. And then he just needs to be connected here. So at this point in time, this graph is complete. Notice out of every single vertex, I have 1, 2, 3, 4, 5 edges. And now every single one of these edges would have to have weights associated with them. So I'm not going to come through here and put all the weights on the graph, but that's what you would need to do if you wanted to do a complete weighted graph from this scenario. In any case, we're going to solve this running the nearest neighbor algorithm, and we're going to run it from Richmond. Okay, so first we're in Richmond. Now I'm going to find Richmond's nearest neighbor. Now as a reminder, that's going to be the city that has the least weight, or in this case it's going to be the closest mileage from the city. So looking across here from Richmond, the cheapest way to get out of there will be this 51. So I'm going to record the weight, and at that point in time, I'm going to Williamsburg. Alright, so now I'm just going to realign myself. I'm over here in Williamsburg. Let's find Williamsburg's nearest neighbor. So looking across all of these weights, it looks like 43 is the lowest. That's in Norfolk. I haven't been there yet, so we'll go there. So I'm going to record the weight, and then now I'm in Norfolk. Coming over here to Norfolk, running across the weights, it looks like 43 is the least, but that's to Williamsburg. That's where I just came from. And then 93 would be the next one, but that goes to Richmond. That was my starting vertex. I'm not going to be able to go back there until I visited all the other vertices. So then at that point in time, the next lowest is going to be 190, which is to Alexandria, which I haven't been to yet. So I'll record the city and then record the weight. Now at this point in time, out of these 6 cities, I've been to 4 of them so far. So right now we're in Alexandria, running across here. The smallest number is to Winchester. We haven't been there yet, so we'll go there next. Alright, so after Winchester, we'll come down here, running across this table. The smallest number we're seeing is to Harrisonburg, and we have not been to Harrisonburg yet. So then we're going to go to Harrisonburg next. And I'll record that weight, which is 68. Now at this point in time, I've been to all 6 vertices, so now we'll have to come back home, which was to Richmond. So from Harrisonburg to Richmond is 131. Alright, so here's going to be the tour, which is going to be the order that the cities have to be traveled, and then the weight of the tour. We're going to add all these numbers up. So we get the weight of the tour is 553 miles.